Today's geometry lesson is section 10.4, inscribed angles and polygons. Our essential question is, how is the measure of an inscribed angle related to its intersected arcs? After today's lesson, you should be able to use the relationships between angles and arcs and circles to find their measures. So let's just talk about what the inscribed angles theorem says. The measure of an inscribed angle is half the measure of its intersected arc. Notice in this picture, the inscribed angle sits on the circle itself. The vertex of that angle sits on the edge of the circle. The intercepted arc is the arc between the two rays that creates that angle. There are three different cases for having an inscribed angle. Case number one, the center is on one side of the angle. So the diameter forms one side of my angle here. So this is my inscribed angle right here. This is my inscribed arc. Case number two, the center is inside the angle. So now we see that this is my angle here. The center is inside that. This is my inscribed arc. And case number three, the center is outside of the angle. So this would be the inscribed angle. This would be the inscribed arc. The center is not included in that. All three cases, we still find the angle the exact same way. So the measure of that angle is equal to half the measure of the intercepted arc. So let's look at some examples. So we see number one, we're looking at circle P. It says if the measure of arc D to G, so D to G right here is 45.6, wants to know what are the measures of angle E and angle F. So angle E consists of this angle right here, angle DEG, except angle E. We see that that is an inscribed angle that goes along with the intercepted arc. So the measure of angle E is equal to 1/2 of its arc, 45.6. So half of 45.6 is 22.8 degrees. Now we want to find the measure of angle F. If we look at angle F, we see that that is angle F, angle DFG. It has the exact same inscribed arc. So therefore, the measure of angle F is also 1/2 of 45.6, which is 22.8 degrees. Number two tells me if the measure of arc AT, so arc AT is a semicircle. Remember that a semicircle means 180 degrees. What is the measure of angle RST? So angle RST, this angle. So the measure of angle RST is equal to 1/2 of 180 degrees, which is 90 degrees. Okay, so next page. The measure of arc ABC is 184. So arc ABC, this arc right here, that's 184 degrees. The measure of arc BCD, so from here to here, is 242 degrees. What are the measures of the angles of the quadrilateral? We'll start with angle A. So the measure of angle A, I see, let's see, angle A makes up this angle right here. And so we see that angle A comes with arc BCD is what it describes that. So that would be 1/2 of 242 degrees, which is 121 degrees. So now if I'm looking at angle D, here is this arc ABC. So the measure of angle D is 1/2 of arc ABC, which was 184 degrees. So that is 92 degrees. So now if I look at angle B, that's going to be this arc out here. So first I need to find the measure of that arc. So arc ADC is equal to 360, because the entire circle is 360, minus ABC, which was 184. So that gets me 176. So the measure of angle B is equal to 1/2 of 176, which is 88 degrees. Now all that's left to find is angle C down here. Come back and look at angle C. I don't know the measure of this arc. Okay? And with the other two measures, I'm not able to find that. But I do know that all four angles in a quadrilateral, which ABCD is a quadrilateral, add up to equal 360. So 360 minus my other three angles, 121 minus 92 minus 88. So the measure of angle C is equal to 59 degrees. So we're using this new theorem along with our previous knowledge of the sum of the interior angles of a quadrilateral. So now we have some corollaries to the inscribed angles theorem. We have three of those. The very first one tells me that two inscribed angles that intersect the same arc are congruent. We saw that up there with the very first example that we did. So the measure of angle S, that angle right there, has this inscribed angle, or sorry, this inscribed arc. Angle T also has the exact same arc with it, so angle S and angle T would be congruent. Corollary number 2 tells me an angle inscribed in a semicircle is a right angle. And so if RS is 180 degrees, then angle T is 90. We saw that on example number 2 on the front. And then corollary number 3, the opposite angles of an inscribed quadrilateral are supplementary. So we see that we have an inscribed quadrilateral, RSTU. So the measure of angle R plus the measure of angle T, because they are opposite angles, would have to equal 180. The measure of angle S plus the measure of angle U would also have to equal 180 since they are also opposite angles. So now using all of this information, let's look at some examples. So number 1, given that BD is tangent to circle P at point C, so that is telling me that that's a 90-degree angle. If arc AC, so this arc right here, is 88 degrees, we want to find the measure of angle ACB. The measure of angle ACB. The measure of angle ACB. That has the, that's an inscribed angle of the arc 88, so that's going to be 1/2 of arc 88 degrees. Half of 88 degrees is 44 degrees. So now number 2, using the same circle, given that EG is tangent at circle P at point F, the measure of angle GFC, so GFC, that angle right there is 115 degrees. It wants to know what is the measure of arc FAC, so it wants its inscribed arc. So the measure of arc FAC, so now we're just basically going backwards. They gave me the inscribed angle, which I know is half of my intercepted arc. So to find the arc, it's going to be 2 times the angle, 115 degrees. So 2 times 115 degrees is 230 degrees. Let's look at our next page. Another theorem. So this theorem tells me that the measure of an angle formed by a tangent and a chord is half the measure of its intercepted arc. So here it tells me the measure of angle AED, so that angle right there is what we're looking at, is going to be half the measure of arc ABE, so half of that. All right, so now let's look at some examples. Given that WY is tangent to circle C at point X, what is the measure of arc XZ? So this arc. So we know that the measure of arc XZ is equal to 2 times that angle right there, they told me was 50. So 2 times 50 is 100 degrees. Now, number 2 says, what is the measure of angle VXW? So VXW, this angle down here. I know this arc over here is 196. We just found this arc to be 100. So we know the entire circle is 360. So first we need to find that arc, that missing arc. So 360 minus 100 minus 196 gets me 64. So this arc is 64 degrees. So the measure of angle VXW is 1/2 of that inscribed arc. So half of 64 is 32 degrees. Let's look at another theorem. Theorem 1010 tells me that if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. The converse of that is also true. So if one side of an inscribed triangle is the diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. So here it tells me if the measure of angle ABC is 90, so if this is 90, if and only if A to C is a diameter. So if and only if that's the diameter. Then the converse just told me if AC was the diameter, and I have a triangle inscribed, then the angle across from my diameter, so angle across from D is B, angle B would have to be the right angle. The next theorem we're going to talk about, theorem 1011, says any quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So in this picture, A, B, C, and D lie on circle E if and only if the measure of angle D plus the measure of angle B equals 180, and the measure of angle A plus the measure of angle C equals 180. So now let's use all of this information to work these last two examples. Find the value of each variable. So A, I have quadrilateral QRSP inscribed inside of a circle. So I know that my opposite angles, so I know the measure of angle Q plus the measure of angle S have to equal 180. So 80 plus X equals 180. Therefore, X is equal to 100 degrees. But then I also know that the measure of angle P plus the measure of angle R has to equal 180 degrees. Angle P in the picture is 75. Angle R is called Y. So 75 plus Y equals 180. So Y is 105 degrees. Okay. Our last example. Again, we have quadrilateral JKLM inside a circle. So I know that the measure of angle J plus the measure of angle L has to equal 180. So J is 2A, but L is also 2A, equals 180. So I have 4A equals 180 degrees. So A is equal to 45 degrees. Then I also know that the measure of angle K plus the measure of angle M has to equal 180 degrees. In the picture, the measure of angle K is 4B. Angle M is 2B. Has to equal 180. So 4B plus 2B, 6B equals 180. So B is equal to 30 degrees. All right, that wraps up section 10.4 in Envision, Inscribed Angles and Polygons. Tomorrow we will look at the last section of our circles and then review and take our Chapter 10 test.